We're continuing with section 5.3, and now we're going to work example 2. About 46% of a particular population of dogs is male. If 2 dogs are randomly selected from the population, find the following. Well, let's first just kind of identify what they've told us. They've told us the probability of selecting a male dog from this population. Probability of a male would be, if 46% of them are male, it would be 0.46. That's the probability if I randomly select one dog from this population, that dog would be male. So using complements, the probability that the dog is not male, we'll just say not, even though we know it's a binary thing. It would be male or female, but we'll just say not male, would be 1 minus 0.46 or 0.54. So that's what they've told us at the beginning and stated in this problem. Now, did they tell us what procedure we'll be using? With replacement or without replacement? No. So we're not told if it's with replacement, so we will assume that it is with replacement. So I'm just going to make a note that I'm going to use with replacement. And what we'll eventually understand is when you have, they didn't tell us how large the population is, but if you're just selecting 2 out of a large population, we can assume it's with replacement. So let's write what we're looking for. We're looking for the probability that on the first trial we get a male dog, and on the second trial we get a male dog. Both will be male. And means multiplication. On a multi-stage problem like this, we're going to have 2 selections. So the probability that the first one is male, well, it says the probability of male is 0.46. And if the probability of the second one is not affected by the first one, which is true when we use with replacement, then the probability that the second one is male is also 0.46. So we can multiply that. Another shorthand way to write it, you don't have to do this but for just 2, but it can come in handy if you understand that. Then if we're selecting 10, you won't write 0.46 10 times. You'll know you can write 0.46 to the 10th. So it doesn't seem like a big deal to write it twice, but when you're selecting more than 2, if that number, instead of 2 dogs, it was more like 10, you wouldn't really want to write that 10 times. Okay, so we just calculate this and you get 0.2116. Let's go to 3 decimal places. That would be 0.212. Okay, part B. The probability that at least one of the dogs is male. Okay, so remember the probability at least one of the 2, because we're going to pick 2, is male. That's what we're looking for. Well, remember we saw that the probability of at least one is equal to 1 minus the probability of none. Sort of rhymes there. 1 minus the probability that none of the 2 are male. Okay, so the first one is not male and the second one is not male. Well, that's why we got the probability of not male, because we're going to use that. So that equals 1 minus, I'm going to use a bracket here because none of the 2 are male, would be the first one is not male, that probability was 0.54, and multiplication, the second one is not male. Of course, I could have again raised 0.54 to the second power. But remember, it's 1 minus the probability of none. So this ends up being 0.7084, or rounded to 3.708. So it's really handy and really necessary to know how to calculate at least one. Probability of at least one is 1 minus the probability of none. And how do you get no males? The first one's not male and the second one's not male. How would we answer part B if 3 dogs were randomly selected? So part B, we would say probability at least one of the 3. If 3 dogs are selected, one of the 3 is male. Well, we'd say that's 1 minus the probability that none of the 3 are male. So again, 1 minus, if I need 3 dogs to not be male, the first one and the second and the third, see, here's where it comes in handy. I'm going to write the same number 3 times, multiply 3 times. Why not just raise it to the 3rd power? That's a lot easier than writing it 3 times. And of course, if we select 10 dogs, as I said before, you wouldn't want to write that 10 times. Okay, so 0.54 to the 3rd, then we 1 minus that, and you get 0.8425, or approximately 0.843. Okay, and recall what that, we could change these to percents and talk about the fact that if the probability of male is 0.46 or 46%, the probability, if you choose 3, that at least one of them is male, is 84%. Move that decimal 2 places, 84.3. That's a way to interpret this. Okay, we'll continue with part 4 in the next video.